A shaft runs at 800 rpm and drives another shaft of 150 rpm. So we have driver shafts N1 is equal to 800 and driven shaft N2 is equal to 150. Through a belt drive, the diameter of the driving pulley D1 is 600. Determine the diameter of the driven pulley in the following cases. First is neglecting the belt thickness. Second is taking the belt thickness as 5 mm. Assuming case 2, that is the belt thickness you have to consider, and we have total slip is 4%. Again you have to solve the case 2, assuming the slip of 2% on each pulley. When we derive the equation for velocity ratio, we have N2 by N1 is equal to D1 plus T upon D2 plus T into 1 minus S by 100. This time we have neglected the product of S1 into S2, and the equation is simplified as 1 minus S upon 100. In the first case, you have to neglect the belt thickness, that is the value of T you have to neglect, and the value of S you have to neglect. Then N2 by N1 is same as D1 by D2. So N1 represent here the driver speed is equal to 800 rpm. N2 represent the speed of a driven, that equal to 150 rpm. Diameter of a driving pulley D1 is known is equal to 600 mm. We have to find out the value of D2 for 4 different cases. In the first case, the belt thickness is neglected, so VR is same as equal to N2 by N1 is equal to D1 divided by D2. So N2 is same as equal to 150, N1 is equal to 800, diameter of a driver is 600, and diameter of driven you have to find out, that is value of D2 you have to find out. So in this case we get D2 is close to 320 mm. Second case you have to consider the belt thickness. So we have N2 by N1 is D1 plus T upon D2 plus T. So if we consider the belt thickness, then we have N2 by N1 is equal to D1 plus thickness T divided by D2 plus thickness T. N2 value is same as equal to 150. N1 value is same as 800. Diameter of the driver pulley is 600 plus thickness is 5 divided by diameter of a follower plus thickness is equal to 5. Diameter of follower is 317.7 mm. In the third case, you have to again find out the diameter of the follower, assuming the total slip S is equal to 4%. We'll use this formula and we'll assume the product S1, S2 is very small. So we have N2 value is same as equal to 150. N1 will be equal to 800. Diameter of the driver is 600. Thickness you have to take as 5 divided by diameter of the follower you have to find out plus thickness is equal to 5 into 1 minus S, which is 4 divided by 100. Again solve this. So we have diameter D2 is come out to be 304.88 mm. But he says that the slip of 2% on each pulley. In that case, we'll use this formula instead of the bracket. So this bracket is replaced and we'll consider the effect of S1 plus S2. So in this case, we have VR is N2 by N1 is D1 plus T upon D2 plus T into 1 minus S2 by 100 minus S1 by 100 plus S1 S2 divided by 10 to the power 4. N2 is same as equal to 150. N1 is equal to 800. Diameter is 600 plus thickness is equal to 5. Diameter of the driven pulley you have to find out plus thickness equal to 5 into 1. S1 and S2 each is equal to 2% is 2 divided by 100 minus 2 divided by 100 plus 2 into 2 divided by 10 to the power 4. Contribution of the last quantity is very small actually, and we hardly get any change in the diameter of driven pulley. So exact calculation of D2 in this case is equal to 304.9 mm. So there is a hardly any change in the calculation. It's a 0.88 mm and 0.9. So there is an error of only 0.02. That is a negligible value. We'll take here one more numerical. A shaft is running at 200 rpm is to drive a parallel shaft at 300 rpm. The pulley on the driving shaft is 60 cm in diameter. Calculate the diameter of the pulley on the driven shaft. First you have to neglect the belt thickness. Second you have to consider the belt thickness into account, which is 5 mm thick. Assuming the latter case, that is 2, a total slip of 4%. So S value is given, which is S1 plus S2 is equal to 4%. The shaft is running at 200 rpm, that is the driver speed is given as 200 rpm. To drive a parallel shaft, so drive shaft has a speed equal to 300 rpm. The pulley on the driving shaft has a 60 cm diameter, that is we have 600 mm is the diameter D1, D2 you have to calculate. In the first part you have to neglect the belt thickness, so we have N2 by N1 is equal to D1 by D2. The generalized formula is N2 by N1 is equal to D1 plus T upon D2 plus T. This time thickness is neglected and the slip is also neglected, so we get N2 by N1 is equal to D1 by D2. N2 is same as equal to 300 divided by N1, which is equal to 200. D1 is equal to 600 and D2 we have to find out. So neglecting the belt thickness, we get the value of D2 is close to 400 mm, that is 40 cm. If the slip is neglected and the thickness is equal to 5 mm, then we have N2 by N1 is same as D1 plus thickness upon D2 plus thickness. N2 by N1 is same as 300 by 200. So we have 300 by 200 is equal to D1, which is equal to 600, thickness equal to 5 divided by D2 plus thickness, that equal to 5. So we'll get the value of D2 is close to 39.83 will be cm. Actually it's a 398.3. I have written the answer in cm, that is 39.83. Considering the thickness and the total slip of 4%, VR is equal to N2 by N1 is D1 plus T upon D2 plus T into 1 minus S by 100. We have N2 by N1 is same as 300 by 200. So we have 300 divided by 200. D1 is same as equal to 600. Thickness is equal to 5 divided by D2 we have to find out, plus we have thickness is equal to 5 into 1. Total slip is equal to 4% is 4 divided by 100. So including the thickness and the slip, the diameter of the driven pulley D2 is equal to 38.22. Again this answer is basically 382. You have to write down in cm is 38.22 cm. In a flat belt drive, the slip between the driver and the belt is 1%, that is S1 is equal to 1%, and that between the belt and follower is 3%, S2 is given as 3%. Driver and follower pulley diameters are equal, that is D1 is same as equal to D2. Velocity ratio you have to find out. This time thickness is not given, so we'll neglect the effect of thickness. So slip S1 is equal to 1%, slip S2 is equal to 3%, and we have D1 is same as equal to D2. We'll assume the value of T is almost equal to 0, that is negligible thickness. So generalized formula to find out the velocity ratio is N2 by N1 is equal to D1 plus T upon D2 plus T into 1 minus S2 by 100 minus S1 by 100 plus S1 into S2 by 10 to the power 4. This time thickness you have to neglect. D1 and D2 is the identical value. So this ratio here, this term is same as equal to 1 into 1 minus S2 is equal to 3 by 100. S1 is equal to 1 divided by 100 plus we have S1 into S2 is 1 into 3 divided by 10 to the power 4. D1, D2, they will cancel out. Effect of T is equal to 0. So this equation will give you the velocity ratio is very close to 0.9601. That is approximately equal to 0.96. 0.96 means choice D is correct choice. Similar to the sleep, we have one more concept is creep. So when we have a driver and the driven pulley are connected by means of a belt, then we have a tension on the bottom side and the slack on the top side. Because of the elastic in nature, we know here as that because of a tension, the member length will increase, and due to the compression, the member length will decrease. So belt has a one area where the tension is more, that is T1 is more as compared to the other side. So that side is called as the tight side. So T1 here is called as the tight side and T2 side is called as slack side. On the tight side here, the belt length increases, whereas on the slack side, due to the compression, the belt length decreases. This means that the driving pulley will get more length of the belt and the driven pulley will get the less length of the belt. So this uneven stretch of the belt around to two different sides of the belt causes some relative motion of the belt against the pulley, and this phenomena is called as creep, but there is a slight difference between the creep and the slip. In the case of a slip, there is an air gap in between the belt and the pulley, and that is the reason there is an insufficient friction between the belt and pulley, where creep is due to the uneven stretch due to the elastic property of the belt, and the slip is due to the presence of air between the belt and the pulley. Although the phenomena is different, both one thing is a common. Both affect the velocity ratio of the belt drive, thus affect the power transmission. So both the creep and the slip will affect the power transmission. Basically the slip is due to the gap between the belt and the pulley which is filled with the air, and creep is a phenomena which is based on the concept of tension and compression. The tight side is taken as a tension and the slack side is taken as compression. Whenever any member which is in tension, then the length of that member will increase. So the length of tight side will increase, and if any member is under compression, the length will going to decrease. So the top side we have shorter length. That phenomena is called as creep. So almost same phenomena, the slip and creep, and both will affect the velocity ratio and hence the power transmission. So in the case of the creep, there is a slip occur because there is a difference in the tensions on the two sides. If sigma 1 and sigma 2 the stress in the belt on the tight side and the slack side respectively, and E represent the Young modulus. So due to the changes in the length, there is a relative motion between the belt and the pulley surfaces, which one is known as creep. And when we have a creep, in that case we have velocity ratio VR, which is nothing but the ratio of N2 by N1 is given as D1 by D2 and is multiplied by a factor. This factor is given as E plus under root of the stress in the slack side pulley divided by the Young modulus plus we have under root of the stress on the tight side of pulley. Using this equation, we can calculate the velocity ratio. In the case of creep, we should provide the value of Young modulus, the value of the stress in the tight side, value of the stress on the slack side, and the two diameters D1 and D2. The power is transmitted from pulley 1 meter diameter running at 200 rpm to a pulley of 2.5 meter diameter by means of a flat belt. So we have D1 is given as 1 meter, N1 equal to 200, D2 equal to 2.5. Find the speed loss by the driven pulley as a result of the creep. If the stress on the tight side, that is the value of sigma 1 is equal to 1.44, on slack side, that is the value of sigma 2 is equal to 0.49, the Young modulus for the material is 100. So we can calculate the value of N2 using the equation as N2 by N1 equal to D1 by D2 into E plus under root of sigma 2 upon E plus under root of sigma 1. All values are known, so we are very much able to calculate the value of N2. Second case, we don't have to consider the creep. In that case, we have N2 by N1 is simply D1 by D2, and these two difference we have to find out. So we have diameter D1 is same as equal to 1 meter. Diameter D2 is equal to 2.5 meter. Then we have rotational speed of a driver is known, that is N1 is known, equal to 200 rpm. Rotational speed of driven you have to calculate and compare with creep and without creep. Sigma 1 represent the tension on the tight side, that equal to 1.44 Newton per mm square is same as megapascal. Sigma 2 is equal to 0.49 megapascal, and we are given the value of Young modulus E, which is equal to 100 megapascal. So if we consider the creep, then we have N2 by N1 is equal to D1 by D2 into E plus under root of sigma 2 upon E plus under root of sigma 1. N2 we want to find out. Value of N1 is known to us, that equal to 200. Diameter D1 is equal to 1 meter. Diameter D2 is equal to 2.5 into. We have Young modulus is equal to 100 plus under root of stress on the slack side is 0.49. Whole thing is divided by Young modulus is equal to 100 plus under root of the stress on the tight side is 1.44. So you have to just remember this equation, and then you can calculate the rotational speed of the driven under the creep. This value is come out to be 79.67 rpm. And if the creep is neglected, this additional factor you don't have to consider. So in that case, we have N2 by N1 is simply D1 by D2. So we have N2, let's call this value as N2 prime divided by N1, which is equal to 200. The diameter D1 is equal to 1 and diameter D2 is 2.5. So neglecting the creep, we have the speed of a driven pulley is N2 prime come out to be 80 rpm. So naturally the value of N2 prime is more, that is the creep is neglected, we have higher value, and when the creep is considered we have lower value. So we have a speed loss by driven pulley due to creep is nothing but N2 prime minus N2, which is same as equal to 80 minus 79.67 rpm. So you will get a decrease in the speed equal to 0.33 rpm. The creep in the belt drive is due to the material of the pulley, material of the belt, unequal sizes of the pulley, or unequal tension on the tight and the slack sides of the belt. So choice D is correct here, because as far as the slip is caused due to insufficient friction between the belt and pulley, whereas the creep is due to the uneven stretch, which one is the elastic property of the belt and depends on the tension on the tight side and the slack side. So there is an unequal tension on the tight and slack side, due to which the creep will occur. Our choice D is the correct choice. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.